Roman roads were rigid, fixed in stone, impossible to reroute once built. The internet is the opposite, fluid, self-healing, able to reroute data around a failure in milliseconds. So how can two systems built on completely opposite philosophies be solving the same underlying problem? That contradiction is exactly where this gets interesting. Imagine running a company with offices on 3 continents, but every email has to go by physical courier. No phones, no instant messages, just a person traveling by whatever transportation exists, carrying your words from one office to another. Now scale that up. Not a company, an empire. 60 million people, spread across roughly 2.5 million square miles, from Britain to North Africa to the Middle East. No email, no courier trucks, nothing faster than a horse. This is the problem every system faces once it grows past the size a single person can personally oversee. Distance breaks control. A ruler, a general, or a merchant can only govern what they can reach in time to matter. Without some way to physically link distant places together, growth simply stalls at the edge of how far someone, or something, can travel before the opportunity, the order, or the emergency passes. For Rome, this wasn't a side issue. It was existential. An empire that couldn't move legions, tax revenue, and orders quickly enough would fracture into pieces too far apart to hold together, which is largely what happened once its road network began to decay. The same problem exists today, just at a different scale. Information, commerce, and coordination have outgrown what any single city, or even any single country, can contain on its own. Lose the connection, and a modern business or government loses the ability to function, the same way Rome did when the roads gave out. And in both cases, the hard part was never the two ends of the connection. It was everything in between. Rome's answer to distance wasn't a single invention. It was a network, and the network mattered more than any individual road. At its height, the Roman road system stretched roughly 250,000 miles, with around 50,000 of those miles paved. That figure alone doesn't explain much. What made the system work was standardization. Roman roads were built to a consistent design, layered construction, a compacted stone base, a durable surface layer, and drainage ditches on either side to prevent erosion. A road engineered in Gaul followed largely the same construction logic as one in Syria. That consistency meant a legion, a magistrate, or a merchant could move through completely unfamiliar territory and still know exactly what kind of surface they were traveling on. But the roads themselves were only half the system. Rome also built the cursus publicus, a state-run courier and relay network with way stations placed at regular intervals along major routes. These stations offered fresh horses, rest, and lodging for official messengers and government business. This turned a single long journey into a chain of shorter, faster relays, dramatically cutting the time it took for information and orders to move across the empire. A message could cross hundreds of miles in a matter of days, not weeks, because no single horse or rider had to make the entire trip alone. It's worth being clear about priorities here. These roads weren't built primarily for trade. They were built for the military and the administration of empire, to move legions quickly to wherever they were needed, and to keep provincial governors connected to Rome. Commerce benefited enormously, but it was a byproduct, not the original design goal. Redundancy mattered just as much as standardization. Rome didn't rely on a single route between major points. Multiple roads often connected the same regions, so that damage, weather, or local unrest blocking one path didn't sever the connection entirely. Combined with the relay stations of the cursus publicus, this meant the system could absorb local failures without the whole network breaking down. This is really what Rome invented. Not roads, but a standardized, redundant, actively maintained network with built-in relay infrastructure that turned impossible distances into manageable ones. The stone was just the material. The real engineering was the system built on top of it. That network held the empire together for centuries. Then it began to decay, and it would take well over 1,000 years before anything replaced it at a comparable scale. By the mid-20th century, the problem hadn't gone away. It had gotten bigger and stranger. This time, the challenge wasn't connecting provinces across an empire. It was connecting machines, computers built by different manufacturers, running different software, that had no shared way of talking to each other at all. The starting point was ARPANET, a project funded by the U.S. Department of Defense's Advanced Research Projects Agency, which went live in 1969, linking a handful of university and research computers. Like Rome's roads, it began as a project tied to government and military priorities, not commercial ones. But ARPANET alone couldn't solve the deeper problem. Connecting a few computers on one network was one thing. Connecting different networks, each with their own rules, into a single unified system was something else entirely. That deeper problem was solved by two engineers, Vince Cerf and Bob Kahn, who in 1974 introduced what became known as TCP/IP, Transmission Control Protocol and Internet Protocol. This is the modern equivalent of Rome standardizing road width and construction. TCP/IP gave every network, regardless of who built it or what hardware it ran on, a shared set of rules for how information should be broken up, labeled, addressed, and reassembled. Once that standard existed, it no longer mattered what was happening underneath it. Any network that spoke TCP/IP could connect to any other network that did the same. This protocol, not any single cable or machine, is the Internet's actual road system. The physical layer matters too. Much of global Internet traffic still travels through undersea fiber optic cables spanning oceans, linking continents in a way that, structurally, isn't so different from a road linking two provinces. But the more important shift is in how the Internet moves information across that physical layer. Roman roads carried a traveler along one fixed path from start to finish. The Internet uses packet switching, breaking information into small pieces, each of which can travel independently, taking whatever route is available at that moment and reassembling only once every piece arrives. If one path is congested or broken, traffic reroutes automatically, often in milliseconds, without anyone noticing. That's the Internet's version of Rome's redundancy, pushed much further. Rome built multiple roads so that damage to one route wouldn't sever a connection. The Internet goes a step beyond that. It doesn't just have alternate paths, it actively detects failure and reroutes around it in real time, without waiting for a human to notice something broke. So the Internet solved the same underlying problem Rome did: standardize the connection, then build in redundancy so no single failure takes the whole system down. What changed is the material. Rome's infrastructure was fixed and physical, carved into stone and dirt. The Internet's infrastructure is a protocol, a shared standard that can run on top of almost any physical hardware, adapt in real time, and be upgraded without ever having to repave a single road. Strip away the stone and the fiber optics, and both systems turn out to be built from the same four parts. First, a pathway, something that physically or digitally connects two distant points. For Rome, that was the road itself. For the Internet, it's the cable, the wireless signal, the physical medium data actually travels across. Second, a standard, a shared set of rules that makes the pathway usable by anyone, not just its original builder. Rome had consistent road width, construction, and design. The Internet has TCP/IP, the protocol that lets any device or network speak the same basic language. Third, relay points, places along the way that keep a long journey from depending on a single unbroken leg. Rome had the way stations of the cursus publicus. The Internet has routers and servers, constantly passing data along toward its destination. Fourth, redundancy, a way to survive local failure without losing the whole connection. Rome built multiple roads between major points. The Internet reroutes data automatically the instant a path fails. Pathway, standard, relay, redundancy. Different materials, same architecture. That architecture reveals similarities that go deeper than the obvious. Both connect distant places. Both systems prioritized standardization as the actual innovation, not the physical medium. A Roman road's value came from being built the same way everywhere, so anyone could predict how to use it. The Internet's value comes from TCP/IP working the same way on every network, so any device can join without needing custom infrastructure. In both cases, the boring, invisible standard is what made the visible infrastructure actually useful at scale. Both systems also treated the connective infrastructure as more valuable than any single thing moving through it. No individual message crossing the empire mattered as much as the road network staying intact. No individual email or web page matters as much as the Internet's core protocols continuing to function. And in both cases, The earliest and most demanding users were state and military institutions. Rome built its roads primarily for legions and administrators, with trade benefiting afterward. ARPANET was funded by the U.S. Department of Defense, with civilian and commercial use following once the underlying system proved out. But the differences matter just as much, and forcing a false symmetry here would be misleading. The most important difference is fixed versus adaptive routing. A Roman road, once built, could not reroute itself around a landslide or a washed-out bridge. Someone had to notice the damage and repair it, or travelers had to find another road entirely. The internet doesn't wait for a human to notice. When a connection point fails, traffic reroutes automatically, often before anyone downstream ever registers a delay. There's also a difference in how failure looks. A blocked Roman road was visible. A traveler could see the obstruction, and word could spread that a route was unsafe or unusable. Internet failures are frequently invisible. A dropped or rerouted packet of data usually never registers with the person sending an email or loading a page. The system absorbs the failure silently, which is a strength, but also means problems can persist without users ever noticing something went wrong. And ownership diverges sharply. Rome's road network answered to a single centralized authority, funded and maintained by the state. The internet has no single owner. It's a distributed patchwork of government-funded origins, private internet service providers, corporations, and international standards bodies, all cooperating through shared protocols rather than centralized command. Underneath all of this sits a pattern that goes beyond either roads or cables specifically. Any system that grows past what a single person, city, or authority can directly oversee eventually faces the same choice: standardize the connection, or stay capped at the edge of direct control. Rome chose standardization through consistent engineering. The internet chose standardization through shared protocol. Neither system succeeded because of clever endpoints. Both succeeded because they invested in the unglamorous, standardized middle, the part connecting everything else. That's the universal lesson underneath both systems. Connectivity at scale was never really about how smart or capable the endpoints were: a legion, a governor, a laptop, a server. It was about whether the connective tissue between those endpoints was standardized, redundant, and maintained well enough to be trusted. The road and the protocol are both, by design, unglamorous. That's exactly why they were able to scale as far as they did. Any system that skips investing in that boring middle layer eventually hits a ceiling, no matter how impressive its endpoints become. Rome's roads eventually crumbled, and it took centuries before anything replaced them. The internet's protocols are still young by comparison, untested by anything like the kind of collapse Rome went through. So here's what I want to know. If the internet's connective backbone ever failed the way Rome's roads did, what do you think would replace it? And would we even see it coming this time? Drop your guess below.